Welcome back, everyone, to the AI Dev World main stage. I'd like to introduce your next speaker. Antonio Alegria is the head of AI at OutSystems. And Antonio, whenever you're ready, you can go ahead and take it away.
Thank you, everyone, for being here. Hi, everyone. I'm Antonio. I am head of AI at OutSystems. And so OutSystems develops a modern software development platform that is visual and encompasses the whole development lifecycle, from programming to deployment to monitoring. And our platform is a visual development platform that enables you to create all kinds of applications, including mission-critical applications with higher productivity and lower skill. And since software development productivity is really in our blood, we decided 3.5 years ago to invest a lot in research and development on AI applied to software development, with several patents and papers published, as well as real-world capabilities shipped already. Today, I really hope to give you an overview of what's happening in the field across the industry and academia, what are the key challenges, and also what are the top 3 learnings we took from our experience, and which you can perhaps apply to your own use case. Let's start by looking at what software development is in its simplest form, distilling it to its simplest form. So software development can be seen as a process of translating a vision and a set of requirements into code that is then built and deployed into a running application, which is then used by users or by other systems. And this application, used by these other users and systems, provides feedback directly or indirectly through telemetry back to the developer, who then iterates on the app through code. Now, 10 to 15 years ago, these cycles of development probably took years for most companies. And more the expectation is that this cycle is being crushed. Between feedback and change is going down to months, weeks, or even days for some of the most advanced companies. And the companies who can really accelerate this cycle are the ones who are more successful and can compete more effectively. The thing is, you clearly see a gap between that is increasing between the companies who can have the top talent and the top technology that can make this work and other companies. This is one reason why we constantly see Silicon Valley disruptors overtaking companies with decades of experience and market penetration, right? And I show this number, and this number tells the story of why that happens as well. This is a big part of it. This is the number of unfilled software development positions in the US predicted for this year, as reported by the US Bureau of Labor Statistics, and also from the Co.org nonprofit. So the lack of talent is the number one obstacle CIOs and CTOs identify as keeping them from achieving their objectives, according to a recent Gartner study. Now, this issue, unfortunately, is not distributed evenly. You have the top tech companies, many of which are represented here today, which are able to acquire the best talent and above market wages. But a lot of other companies struggle to keep up in that arena, compromising their competitiveness at the end of the day. And this gap that we see is increasing, and it happens because more and more, all of the companies need to be really, at their essence, software development companies to compete. Everything is digital. And COVID accelerated this drive towards continuous digital innovation. And this demand is outpacing the number of skilled developers that are being trained, but as well as it's outpacing the increases in productivity for each developer. But why is that? If we look at how development productivity and ease has continuously improved, we see that since the invention of computing, the main drivers for this have been improvements in programming languages and associated frameworks, as well as improvements in hardware, of course. But programming language, associated frameworks, as well as the development tools, user experience, usually called developer experience, have been the things that have improved developer productivity and have reduced the learning curve for more developers to participate in the digital ecosystem. We're talking about better IDEs, better programming languages with higher level of abstractions, visual programming and low-code platforms, etc. These improvements have, however, been incremental, not exponential like what we see in hardware with the Moore's law, right? So you have all of these needs, all of this demand going, but the improvements we're seeing on the tooling is not keeping up with that. Now, this is where we believe AI can make a real difference and is already starting to make a real difference. So AI is enabling us to change this equation, and it promises to transform software development with new levels of productivity and lowering the skill barrier, opening it up for more people, many more people, to create custom fit-to-purpose software. What's incredibly powerful about this is that latest developments in AI show that it's one of the areas that is most taking advantage of the Moore's Law. Taking this acceleration power to the process of software development itself will be transforming the levels of productivity and the ease during this decade that we're going through. And one thing that is really important is to understand is that in this equation is that for this transformation to occur, you will eventually have to design your programming languages, your developer experience with AI in mind. It's going to yield new kinds of developer tools, and that's where you're going to see the real transformation. But how can AI help and be integrated in the development process? Let's look at that. So going back to our software development analogy, we can see AI as an augmenter of the developer's skill, providing suggestions, recommendations, and automations that the developer can use to be more productive, to develop with higher quality or learn faster. These AI bots are trained, with software development data. We're talking about code, the code itself, but also logs and runtime performance data and usage data from the applications. And just like developers get better as they need to go through multiple projects and learn how to deal with different situations, right? Deal with different corner cases, go through some bugs, some debugging, experiences. The principle here is that you can train AI models to learn from thousands of projects, millions of code bases, and you can take that knowledge, package it, and use that to augment the developer. That's kind of the core principle we're trying to achieve here. And the way I see this set of AI capabilities is what I call an AI tech lead, that essentially is virtually sitting next to the developer and helping them, augmenting their skill. You build this knowledge right into the development tools. That's kind of the first stage, and that helps the developer through this iteration cycle as they are developing. Okay, but what does AI-powered software development tools and capabilities look like today? When I started working in this area 3.5 years ago, AI on code was a mirage. It was, there was some initial research, some cool demos, but nothing really concrete that was being used in the real world at scale by developers. But we're seeing more and more good examples, and I believe that 2021 was a key year in that transformation, and we're going to see that accelerate in the upcoming years during this decade. So let's look at a few of these examples. One of the most obvious ways AI is being used in software development is in the area of code completion. It's kind of a no-brainer, right? Classic systems for code completion give you syntactically correct suggestions. We're talking about IntelliSense or whatever you might have in IntelliJ or in Eclipse on your IDEs, right? But AI-powered code completion systems like Kite and Tab9 we're showing here, they were trained on millions of code data points, and more than giving syntactically correct suggestions, they can understand the semantics behind what you are building and give you more relevant suggestions adapted to your code base. They also provide a bigger gain for languages without static typing, because in those cases, non-AI powered autocompletion engines are not as good as the ones like, for example, for Java or for C#. This already gives some productivity and learning improvement currently, these systems, and is an example of a simple augmentation without changing the user experience, without changing the developer experience, without changing the programming language. However, this is not, because of that, it's not really going to change too much on how you develop. It's very incremental, but still it's a step up over classical systems. Recently, though, OpenAI and GitHub unveiled Copilot, which is a leap beyond the previous systems. Up until this point, the field of machine learning on code was getting away from pure text-based language models and going more towards more structured models that would encode the graph representation of the code's abstract syntax tree, the data flows, how variables are written and read from. And that's what Kite and Tab9 do, as well as Microsoft's own AI-powered IntelliCode in Visual Studio. But OpenAI's philosophy has been very, very focused on taking self-supervised deep learning based on the transformer architecture and scaling it further and further to reach new levels of quality, which they have proved to be possible despite a lot of doubts from the community in the beginning. And so they went from GPT to GPT-2 to GPT-3, each a massive increase in data and model size and money spent to train these models. GPT-3 already started showing some potential for doing code completion, sometimes very impressively. You might have seen a lot of demos going around on Twitter when GPT-3 was announced on code completion and generating a front-end code and all of that. However, a lot of those demos and examples were very cherry-picked. Like you had to ask the model to give you like 20 different solutions and you would cherry-pick the one that would work, right? And they weren't really usable in the real world while developing. But it did show promise. Then in May this year, OpenAI came out with a collaboration with GitHub called Copilot. Now, this is a next generation code completion feature that doesn't just give you the next line or the next token, but it actually gives you complete code snippets based on the prompt you give it. It was trained with repositories from GitHub, kind of showing one of the biggest values of Microsoft's acquisition of GitHub as well, and kind of was kind of the writing was on the wall, but I think a lot of the industry wasn't seeing that. And they augmented that data set with data sets for programming competitions and other hand-tailored data sets so that the model would perform in certain tasks pretty well. It was also trained to work very well on completing a descriptive comment. So taking advantage of comments that you could describe what you wanted and generating from that. So this used exactly the same architecture as GPT-3, but essentially apply that to GitHub and programming source code, but treated it as just a string of text as well. And so we can see an example here where a full sentiment analysis API call is made just by providing a comment and the function signature. This leads to very interesting results. So this is currently in private beta, but the feedback has been pretty consistent. First, it does have a wow factor right off the bat. It works impressively well when you're dealing with boilerplate, right? When you're, in some programming languages and frameworks, there's a lot of boilerplate, unfortunately. And GitHub shared that around 50% of users that have tested Copilot have kept using it to this day. So there are some interesting adoption numbers, not earth-shattering, but interesting adoption numbers. It's great for trying out libraries you don't know about yet. So you don't know about a library, and this can help you kind of start getting the first draft of what you might want to do with that library. And in a sense, it almost works as cutting the Stack Overflow middleman. A lot of people talk about this, that many of the things that they used to go to Stack Overflow to learn about and to ask about and to question about, they feel that they can now kind of query the model and have the model adapt a solution for their code base, which is pretty interesting and kind of shows where these things can go. It also shows some promise for unit test generation, but with some limitations in real world use. And although it's very mind-blowing and very interesting, it's not all roses and it's not perfect. There's still a lot of work to do. I think the main thing is that the quality of the code is not always great, with bugs potentially being introduced in the suggestions. It's not always easy to check if the suggestions, since they're giving you several lines of code, how do you check if the suggestions are correct or not? And this ends up cutting off your productivity because you can write more lines of code automatically, but then you need to check them, right? And for novices, this is tricky because novices may not have the skill to evaluate and validate and review the code that is being suggested. Recent research from NYU found that 40% of generated code has bugs or vulnerabilities. So this is a big concern, as well as other legal and copyright implications on using open source code to train a model that can then spit out sometimes very similar code to what it was supposedly like GPL, and you would need to share that. The biggest challenge with this system, I think by far, is that it generates a lot of code that you then need to read, understand, and validate, and maybe adapt. And so this ends up not accelerating you fully as much as you would expect, and it doesn't help novices who might not know how to validate the code if the code has bugs, right? So to make this point even more poignant is that this example you see here, taken from their website, has a bug in how a post REST API call is made. So even their standard example they have in their website has a bug or a way that not following the best practices. In any case, it was undeniably a step up in the quality and power of these traditional code suggestion systems. And it's really raising the expectations of what AI can do in software development. And generally, developers have found it to be useful and mind-blowing at times. At the heart of Copilot is the Codex model. Now, OpenAI is opening this up through an API, and one of the more interesting use cases for this code generation model is in enabling the creation of natural language automation for any application, as long as you present a well-documented API. This has the potential to transform how NLU, or natural language understanding, is done at the application level. So in this example that you see here on screen, this is a Microsoft Word. And what they did is that they documented very well the Microsoft Word automation API that allows you to format text, add spaces, and things like that. And essentially, they gave that to the Codex model. They primed the model with that, and then they can describe with natural language or via speech what they want to happen. And essentially, the code has generated its code that is manipulating that API. Before, how you built these systems, you had to use, services like Lewis or things like that, where you had to hand code the intents, and then you had to, get a bunch of utterances to train the model to identify and map natural language to those intents, and then you had to code that up. And now this opens up the door for potentially a complete transformation in how you build these automation systems based on natural language. You just need to make sure that you have the operations you want to support in an API. That API is very well documented. It's very descriptive. And then you can take advantage of this model that generates very good code, and that would translate from natural language to your API calls automatically. It's a complete different paradigm. And more interestingly, there are signs that OpenAI will focus the next iterations of the GPT family on Codex as the engine for general intelligence instead of simply natural language. And this is where you will see AI-powered development get on the mainstream consciousness. AI-powered development has also, and this is something we've been working, and I've been working on for the past years at OutSystems, but AI-powered development has also transformed visual programming and low-code platforms. So this is an example on screen from the Logic Assistant in the OutSystems platform, where we give developers suggestions over the next steps in a way that leverages abstractions and best practice patterns. So here we understand the context and the implicit intent behind what the developer might want, looking not just at the content in the context of the function signature, but also where it's being called. In this case, a mobile app screen that has, several widgets and has a function for managing products. Because of that, we suggest the scan barcode pattern and automatically complete it, together with binding it correctly to the UI and the right variables. The main difference between this system and other state-of-the-art AI systems for traditional programming languages, even Copilot and Codex, is that we operate on a more explicit graph, but we also attempt to provide guidance at a higher level of abstraction. Instead of generating a lot of boilerplate and low-level code, we attempt to teach the system to learn about high-quality, high-abstraction patterns that help developers learn and validate what they're doing. And we take advantage here of graph neural networks to really encode the context and infer the intent behind what the developer is trying to do and provide accurate suggestions. We had a lot of great feedback from our users, not only suggesting it helps in their productivity, but more interestingly, that it serves as their own personal rubber duck to think about we are developing and get to good solutions faster. It helps them think about the problem, and it helps them design the right solution with confidence that they're doing it the right way without bugs. Speaking of quality, AI has not just been helping in terms of code completion and suggestions, but there has been some good examples of using AI to learn how to detect bad code patterns or bugs, and then also learn appropriate patches to it. This example is from 2020. It's called Dr. Repair, where they learn how to fix a program automatically based on the compiler and runtime error messages. There are multiple examples of this kind of code analysis systems being used to automate part of the code review process by flagging common bugs and suggesting fixes. And this is done usually by learning the common diffs and their patches. So looking at the diff history and learning that this is a common change, so this might be a bug, and this is the common patch, and kind of learning to match those two. Another example of AI-powered code analysis is what we do in OutSystems to detect bad code patterns and opportunities for refactoring code, decreasing duplication and technical debt. In this example, we see multiple functions implementing what seems to be the same functionality, although it's pretty different. It uses different variables, different names, different patterns, but could be refactored into a single, most simple version. For this, we use automated reasoning and not deep learning for these use cases, because it gives us the guarantee of correctness that we need to give confidence to developers that we're detecting and fixing code in a trustable way, right? Deep learning can be used to accelerate the process, but we have this logic layer, the symbolic layer that helps us get these things with trust to developers. Finally, there's a great example at Facebook for their internal tools on how AI can help streamline end-to-end quality and CI/CD processes. They have implemented a system that is able to generate tests for their internal applications, find and report bugs in it, generate and propose bug fixes, and then get a feedback loop to learn how to do this better with humans in the loop. And with this, they have been able to automate part of their Q&A process. What's most interesting here is how they have connected this all into a holistic system that evolves over time. It's super interesting, the work they've been doing and using at Facebook to scale their software development processes. So there are already a lot of examples of AI augmenting software development in the real world. Many of them I didn't mention, like a lot of tools for using AI to help in testing applications. Nonetheless, we're seeing in front of our very eyes that this is accelerating, though it's still a very emerging area at the forefront of AI applications. And so with the experience we've garnered in creating these systems end-to-end for the past 3.5 years, we have found a few principles that increase the chance of success in delivering transformational AI-powered features to augment developers. And essentially, these are the three things that help tackle some of the challenges that we mentioned before in terms of quality, etc. First, in order to build systems that ensure great quality in their suggestions and whatever they generate, we propose a feedback loop between code completion, code analysis, and code refactoring. So essentially, we believe that if we built these AI-powered systems, not only for learning what are the most common patterns and how to complete the intent of the user, but also you use that to learn what are the bad code patterns, most common bugs, security issues, or even technical debt issues. And you also learn how to transform this bad code into a good implementation of that, high performance, no security, no bug implementation of that. You can create a feedback loop whereby you use your code analysis engine to detect these patterns, and then you use your refactoring engine to transform these patterns into good versions of that, high quality versions of that, and you apply that. You don't not only surface this in your product, and you create a feedback loop in your product to improve these models, but you also apply these systems to your training data, and you refactor your training data to get rid of bad code and put in some good code instead. Instead of having 10 lines of code, you replace that with a high quality version of an improved library that you could ship. And then your code completion system provides better suggestions, higher quality suggestions, higher abstraction suggestions. And with this, if you also take advantage of that to evolve your programming language and frameworks instead of suggesting 10 lines of code, you replace this by a high level class or a function that already does that, you are speeding up the productivity, but also the readability and the reducing the skill barrier for people to use. So this is something we implement, and it's very powerful. Also, to deal with the complexity of the use cases and the need for understanding a wide, context and very rich semantics, you need to bring forward new ways of modeling data in code. Self-supervised learning is really essential in this area, and code data lends itself very, very well to it, as due to the fact that you don't really have a lot of explicitly labeled data, and that code is very varied across different code bases. And although mega transformer models have shown incredible performance, like Codex and CodeT5, they still struggle with variable binding. And I think that they're going to continue struggling with that. Graph neural networks or geometric deep learning have shown a great ability to encode these semantics very well and can be a very good and more efficient mechanism to tackle these use cases or others. And by complementing these deep learning foundations is the use of automated reasoning, which is able to model all of the constraints and provide a solid logical and symbolical foundation over which deep learning, the probabilistic systems, can operate on. And this is especially critical when you're dealing with code where you want it to be correct, you want it to be, trusted. And this essentially equates us to pushing forward the use of neurosymbolic AI, which pairs, the deep learning, the connectionist view, and the symbolic view of AI. And these two complementing each other create these very powerful systems that go beyond just giving you probabilistic patterns, but also can reason about some of those properties and generate other properties afterwards. And so you're going to see these technical trends not only disrupting this area of AI applied software development, but also other areas of AI application. Finally, you really need to look at this whole area and integrate user experience, product engineering, and AI working together from inception, from research throughout the product development lifecycle to solve these problems. In particular, for UX, It's crucial to involve product designers in the whole process and think from the perspective not only of the user, but also of the machine. You want to create powerful feedback loops. You want to create powerful data engines that will make your models get better as they are used more. This is hard, but has a big payoff. One analogy I've used with product managers and designers in explaining this is showing this diagram and the symbiotic relationship between UX, user experience, and MX, which is machine experience, or how good is the system for the machine to learn and improve, right? Examples of machine experience questions are you storing and formatting data in a structured way? Are you investing in having more good, consistent data versus having a lot of data? Are you facilitating user feedback to annotate data and improve algorithms? Are you giving users a super easy to use UI that, however, prevents you to collect good data and feedback, which then prevents your system to evolve? So this is really important to teach the team and invest in having the symbiosis between UX and MX. So these were the top 3 lessons and pillars to bring the future of this area. But what does this future look like? Let's go back to the beginning. Just a few years ago, this was what software development was for everyone. Today, we're seeing the AI tech lead start to appear and provide more guidance, automation, and validation to developers' work. And with this, improving productivity and reducing the skill barrier. We're still in the early stages, but what will happen as these systems get better and better and learn more and more, as we create a great machine experience and great data engine, what will happen to how we code and test and review? I believe we'll see the roles evolving and the AI bot doing more and the developer becoming more of a guide, inverting their roles. So the person becomes an interpreter of requirements from the user and then translates this at a high level to the bot, who takes care of most of the technical tasks, right? So this really takes advantage of the creativity and the understanding of the human and lets the machine help you with the more grunt work, the technical tasks most of the time. And have the human validate that and guide and say, this is wrong, I wanted you more like this. But can this even go further? It's hard to say, but I can at least envision a future where, we don't know when, where the AI bot can take care of most of the development loop, also understanding the feedback from the user and from the user, understanding what the next iteration needs to be. And this will really crush the development cycle, latency, from even days to maybe seconds or more. However, if we get there, we're essentially reaching AGI, artificial general intelligence. So that opens up a huge set of other questions. So we don't really know what that will mean in the future. I do suggest you go to this URL I have here, ml4code.github.io, which has a lot of the latest research on this area from all across the industry and academia. Nonetheless, for me, I believe that AI-powered software development is sure to be the key ingredient in solving the talent gap, and I'm excited to be moving the field forward. I think we still have a long way to go, but in this journey, we are learning how to deal with this, which I think is the next frontier for AI. And many of these solutions, I think, can be leveraged in your own areas, in your own use cases outside of software development. So I hope you look at this and can extract some value to your own initiatives. And I thank for your attention, your attendance in this session. Thank you.
Thank you so much, Antonio. And thank you, everyone, for joining this session. And if you want to connect with Antonio, his Twitter is right there. So
yes, please follow.
Yes, and that is all for this session. So thank you, everyone, again. And come back in about 30 minutes. We have the next presentation. Right now is a networking break. So thank you all.
Thank you.
And have a good AI Dev World.